Hello everybody, hello. Welcome back to my YT channel. So let's go back to our topic for today. IUPAC naming of organic compounds. So we have here 5 examples. Number 1, 2-methylbutene. Number 2, 2,3-diethyl pentane. Number 3, chloropentane. Number 4, pent 1,3-diene. Number 5, 3-butanol. Number 6, dimethyl butane. Okay. So let's go first with number 1. 2-methylbutene. Then you need to look back. The first step, you need to look for the parent backbone, which is the butene. Okay, so butene from the word butane, so meaning it contains 4 atoms of carbon. So 1, 2, 3, 4. Okay. Oh, I don't use this green because we cannot see, right? This black. 1, 2, 3, 4. Can you see now? Yes, very clear, right? Oh gosh. Okay. So we have an attachment methyl. Okay, so meaning to say an alkyl attachment. So how can you say an alkyl? Alkyl is equal to, okay, alkane minus 1. Okay, now methyl comes from the word methane. Since methane is CH4 minus 1 is going to be CH3. That's why our attachment alkyl is always CH3. Okay, going back to butene. So third step, go to the bands. If it is, or chemical bands, if it is single band, double bond, triple bond. So here, double bond because E and E. Okay, then what is your number? 2. So you need to put the double bond in carbon number 2. Okay, but before starting that, we need to count first the carbon atoms from left to the right. Say 1, 2, 3, 4, and from right to the left. 1, 2, 3, 4. Okay. Get the point? It's really clear, right? So we need to use other pen. Okay. Now 2. So we will start here. 1, 2. Okay. So your double bond will be in here. 1, 2. So double bond here. 2. Okay. Then you attach your methyl in carbon number 2 here. Your alkyl, which is CH3. CH3. And we have now H. Supply the other carbon atoms bands with H. 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 Okay. Get the point. So count the bands. Okay. For carbon number 1, 1, 2, 3, 4. It's okay because carbon contains 4 valence electrons in the outermost shell. Okay, the valence electrons of carbon 4. That's 1, 2, 3, 4. And how many electrons totally banded with hydrogen? It's gonna be 8, following the octet rule. So 1, 2, 3, 4, 5, 6, 7, 8. So that condition or requirement will be the same in carbon number 2, 3, and 4 all throughout. Now, when you count the hydrogens here, that is totally different if there is a double band. So here, so 1, 2, 3, 4. The hydrogen here will be lost because if we add 1 hydrogen, it will become 5 electrons, and the valence electrons of carbon is not 5, it's only 4. Okay, here also in carbon number 3. 1, 2, 3, 4. It's okay. And carbon number 4, 1, 2, 3, 4. So things like that. That's the full structural formula in Fisher projection. Now let's make it condensed structural formula. So you need to put a bracket from the first part, second part, third part. The part what I mean is each carbon atom. Okay, so for the first part we have C. Put C. Count the hydrogen. 1, 2, 3. So CH3. For part 2, okay, there is only one. No, CH3 is here at the top. It's gonna be C, the carbon parent first, then the attachment CH3. Okay. Then in the part 3, we have CH only, right? Correct? Yes, CH only. And part 4, CH3. 1, 2, 3. So CH3. So it's going to be CH3, CCH, CH3. Find the most common with each other that usually repeated. So it's going to be the CH and the CH3. So there are two CH3s. 1, 2. So we'll put CH3, close and open parenthesis, 2. And then check. And we have one carbon only. And there's two CH, right? So CH, close and open parenthesis, 2. So this is now our 2-methyl butene in a condensed structural formula. Okay, and this is our 2-methyl butene in a full structural formula. And now, what is our general chemical and molecular formula? So count all the elements each. So start with carbon. How many carbon? 1, 2, 3, 4. So 4. Hydrogen. Okay. Hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like that. Okay. Take note. In counting also the carbon, you may include the carbon on the attachment. You get the point? So things like that. So you will change now your chemical formula into 1, 2, 3, 4 plus 1 here at the attachment on carbon number 2, it will become C5. Okay. Things like that. So if you try to look at it, you may simply confuse, but 5 atoms of carbon, it looks like a pentane. But your words here, 2-methyl butene, so it doesn't coincide, right? So better do first the structural formula, because you cannot guess that immediately with equivalent general formula and molecular formula. So if that is the case, you are very brilliant without doing the structural formula, or else you memorize that already, but it's impossible to memorize different forms of substances, especially substances or compounds that are complex and not common all the time in the sample problems of our books, in the discussion of our organic chemistry teachers, okay, general chemistry teachers. So usually there's a lot of compounds and substances. We cannot memorize really, especially if the substances and compounds have attachments, especially in organic chemistry. So it looks like we will be perplexed all the time. So for us, it looks like skeptical. The first thing to do is to enable ourselves to make first the structural formula. And after that, it's easy to determine the general formula, molecular formula, chemical formula, and the other types of structural formula in the first place. Okay? That's the answer of number 1. But you don't have to worry, because these 3 forms of presenting to you the formulas could be correct. It depends only the instructions of the examination. Then if there's no such specific instruction that will say, what is the formula of 2-methyl butene, then you can write any. You can do the structural formula, condensed formula, general formula, molecular formula. But the sad thing, if the question is very particular, then even though you answer the correct answer, then it's still wrong. It depends on the instructors if he considers that or not, but usually if you don't follow instructions, it will be wrong. You get the point? So if the question in number 1 will say, what is the condensed structural formula of 2-methyl-butene? And you give this one. This is full structural formula in a Fisher projection, so you will be wrong, supposedly. You get the point? But then if your teachers are good, then you establish good relationship, like you are sip to your instructors and things like that, so it cannot be avoided, then it could be also considered things like that, but it creates bias to the students. Okay, it's not really wrong. No, it's not wrong actually, it's wrong. You need to give favor in which it is not really the correct thing to do. Wow. Okay. Let's go to number 2. Okay, example number 2. 2,3-diethyl pentane. Okay, so the first thing to do is to look at the backbone of the compound. Okay, then there's pentane. Okay, so this pent. Okay, then it involves a lot of single band, that is ENE, pent plus ANA, so pentane. So right now the pentane, the parent backbone of your compound. So 1, 2, 3, 4, 5. It contains 5 atoms of carbon. Now look at your attachment. Okay, it talks about the ethyl, right? And the number is in carbon number 2, carbon number 2 and 3. So put the numbering first from left to right. 1, 2, 3, 4, 5. Right to left. Okay, 1, 2, 3, 4, 5. I say 2,3-diethyl pentane. So we need to put here the attachment from 2 and 3. Okay, because that is di, meaning 2 times putting in carbon number 2 and carbon number 3. Now what is ethyl? So if you look back again to the formula, ethyl is equal to alkane minus 1. Things like that. You get the point? Okay, what is your ethyl? So what is your ethyl? So you need to remember the hydrocarbons. So we start with CH4. The alkyl form will be CH3. So in your sheet of paper, you need to prepare from carbon 1 to carbon 10 with each corresponding alkyl attachment, so that by the time there is an example like this, you will take a look on it and apply that directly. At first, if you found it's too difficult to memorize at first, then you are familiarizing that due to your familiarization every second, every minute, every hour, things like that. Then you can master that somewhere along the way. You get the point? So, second, ethane, C2H6. So here, ethyl, so ethane minus 1. So, your minus here would mean only the atoms of carbon deducted. Okay, not the hydrogen. So if you have 2 atoms of carbon, things like that, so you will deduct that. Okay, first here, just ethane. If you have CH4, it will become CH3. So sorry, it's the hydrogen, C2H5. Okay, C2H5. In the book kasi guys, it's not clear then. Kasi because it's stated there, alkane minus 1. So that would mean hydrogen atoms minus 1 in that particular hydrocarbon. You get the point? So it's not clear also, right? Okay. So say ethane minus 1, it is the atoms of hydrogen that will be deducted. So it will become C2H6 minus 1. It will become C2H5. You get the point? Not the carbon. Okay? I'm confused at first because there's no clarity of the formula. Okay? just saying, alkane minus 1, and what is the atom deducted? So that's why I keep on illustrating so that I may understand really what is being deducted. Okay, got the point? Okay, because when I was in college, I'm not doing like this. Okay, so this is so special that, okay, that we learn in this way, and it's easy to share this kind of information. So it looks like a strategy for easy comprehension. It is not detailed, okay, because we are not really studying here in a university, in an institution that we take time for first semester, second semester. This is only vlogging, so we need to introduce simplified, quick discussion that we can understand really on the spot what is really the point of doing that kind of subject or topic, right? Is the point. So we don't do here laygay in Bisaya, pinalaygay style. We don't delay the understanding. We need to go straight for the technique and the strategy how to understand in an easy manner. Okay, things like that. So C2H5. Okay, then you have to put the C2H5 here. C2H5 in carbon number 2 because it says in carbon number 2. Carbon number 3 C2H5 also. Okay, so this is gonna be now your diethyl pentane, and now you need to allocate your hydrogen in each carbon. Oh, hydrogen here, spread the hydrogen. Okay, like that. So in carbon number 2, okay, carbon again has a 4 valence electrons in the outermost shell. So count 1, 2, 3. They're still missing another one, so put H. Okay, and carbon number 3, 1, 2, 3. So they're still missing one H. Okay, because if it is not complete, so it will not be happy for a carbon to have a insufficient attachment of hydrogen. Okay, so he want to be justified by fair acceptance of his blessings or property, things like that. Okay, if you try to put that in real life situation. Okay, carbon number 4, we have H here, then H, H, H. So this is your full structural formula of 2,3-diethyl pentane. Now, make your condensed structural formula. So we need to divide. We put subdivision in each carbon atom. So carbon number 1, subdivision, like a wall. Okay, so carbon number 2, subdivision. Carbon number 3, subdivision. Carbon number 4, wall. Wall or compartment, you can name that whatever terminology you want in English language, as long as it is synonym. Okay, it doesn't matter as long as we understand. You get the point? Okay, now in compartment number 1, well, so here, right, in carbon number 1, so count the hydrogens and the carbon. So carbon first, we always put first the parent, okay, element, okay, meaning the backbone. The backbone is the carbon here, okay, so carbon, attachment, hydrogen, 1, 2, 3, so H3. Oh, go to compartment number 2, carbon, hydrogen, 1. But for the attachments, so many, see? 5 plus 1, 6. Right? Things like that. So 6. Or you can say directly CH here and C2H5. Okay? Okay? Things like that. And then compartment number 3, okay, C, okay, H here, and C2H5. Okay. Carbon number, compartment number 4 rather, we have CH2. Compartment number 5, CH, how many H? 1, 2, 3. Okay, now count the common of each compound. So we have the common CH3, no? We have common carbon, CH, C2H5, and C2, okay, CH3, common, CH2 is not common in this case. We don't have other CH2 here. Okay, So go to CH3. CH3 how many? So it's in the first and the last. So CH3, close and open parenthesis, 2. Okay, CH, 1, 2. So CH, close and open parenthesis, 2. C2H5, 1, 2. So C2H5, close and open parenthesis, 2. If 3, C2H5, close and open parenthesis, 3. But in this case, only 2. Okay, CH2, there's only 1. Okay, so this is your condensed. CH3, okay, parenthesis 2. CH, parenthesis 2. C2H5, parenthesis 2. And CH2. This is your condensed structural formula. And this is your full structural formula. And what is your general formula? Count each element. Okay, carbon. Okay, things like that, no? Okay, guys. So, I love blue. Let's try blue. Okay, so this is your first two. The first will be your full structural formula. Second, condensed structural formula. And third, our molecular formula, general formula, or chemical formula. So, certain way we always give 3 names to maximize our understanding for terminology. Because, you know, in an examination, they will opted to use different terminologies in which the terminology sometimes they use there or they reflect in their exam is not the common that our teachers usually use in their discussion. So this is a trap because if we don't understand the other meaning of a particular technical science terminology, then we will get lost somewhere along the way because we are used to the kind of word that our teachers are always keep repeating. Okay? So if the word will change, then nana. So that's why we need to maximize our learning. Okay? The style of discussion is like this. Okay, so the third will be our molecular formula, general formula, and the chemical formula because they are the same manner. Okay, so number 3. Carbon. How many? 1, 2, 3, 4. Because there are 2 carbons in the attachment in carbon number 2. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. So C9. Okay. Hydrogen. 1, 2, 3, 4. 4 plus 5. 9. 9. Okay. 10. 5. 15. 16, 17, 18, 19, 20. C9, 20. Then count again. So it's very easy to count in your condensed structural formula rather than in the full structural formula because there's a band chuvas. Then it's very easy to count in your condensed structural formula. So count in the structural formulas because it's easy. Okay. 1, 2, 3. 3 times 2, 6. So 2. 6 plus 2, 8. Okay, ang hydrogen. Okay, then 5. Okay, 5 times 2, 10, 18. Okay, then 18 plus 2, 20, correct. Carbon. Okay, 2. Okay, 2, 4. 4 plus 4, 8, then 1, 9. So, perfect. Our chemical formula, general formula, molecular formula of 2,3 diethyl pentane is carbon 9, H20. 9 atoms of carbon and 20 atoms of hydrogen. That's why if the question will say in the examination, write the general formula, then they give like this. It's very difficult. Really, you cannot automatically say that there's gonna be a carbon 9, okay, and 20 atoms of hydrogen and 9 atoms of carbon unless you will do the structural formula or you memorize this even before 2 options. But okay, we are not Superman to memorize every time the variations of the IUPAC naming of organic chemistry, the organic compounds. Nobody is doing it, I think. You get the point? So it would be complicated to do that and not practical. So we're gonna use the structural formula. So that's number 2, 2,3-diethyl pentane. And now class, we go to our example number 3, chloropentane. Okay. So, are you still with me? Carbon number 3. Example number 3. Okay. We have now chloropentane. Okay, you got the point? Usually in an examination, so if there's no number, it's gonna be either both start from the right and start from the left. Okay, because subjective. Once it has a number already, then that would be precise. Okay, but if like this only, there's no number, so you will start from the what is usual to start. You get the point? So we will start to the left, right? Am I correct? Things like that, or whatever. It depends on the examination, what is being cited there, or what is being stated there. You get the point? I need to adjust. Really. Okay, so chloropentane. Okay, again, pentane. So pent, okay, and A and E, single band, pentane. 1, 2, 3, 4, 5. Now, okay, carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, 1, 2, 3, 4, 5. Now, if you try to be true to yourself, actually it doesn't matter where the number really is when you do the attachments, as long as you understand. Because it depends on how the examination is really reflecting or stating there. You get the point? So I told you. Okay, but normally there's no such like this given the specific, and then because for the reason that it's not easy to encode in a computerized exam, the example, the cyclic ring, like that, that's why they avoided that one. Okay, during the board examination, there's no such cyclic ring. Then you need to identify. They will just put in the words. Okay, and you'll be the one to something like that. Okay, or the name of another like this. But there's no such drawing. Okay, what is the Howard? What is the Fisher? Like that projection. For the reason that it looks like very complex to do that in the in the exam. Okay, you get the point. And I don't also remember that the examination also, for example, in math, they draw the shapes like that, a rectangle there, and you'll be the one to put angle of inclination. It's not like that. Always words. You get the point? And variables. Okay? Things like that. Worded problems. And chemical formula like that. And numerical figures like that. You don't have to draw something in question number 1. There's a big circle there and there's a labyrinth. Like there's no such like that. Right? In our school, sometimes our sample problems our teachers draw already the sphere like that. In the actual examination, there's no sphere there in the drawing. Okay, you'll be the one to draw sphere in your brain cells, in your sheet of paper. You get the point? And it will say the sphere, blah blah blah, so and so has a radius like that. Since you know already what is the sphere in your brain, then you need to draw in a scratch paper like that. But the question will not draw. You got the point? The shapes. You got the point? What I mean? Okay. Because it would be tasky and tedious for an examination a questioner to be like that. No, it would be better always statements. Now statements, numbers, and variables. Okay. You get the point. So it depends also to the type of question. Maybe the style of PRC is always like that, but the other types of examination are also having shapes. For example, in company entrance examination, okay, during acceptance of, for example, only cadet engineers, and you will become one of the engineers of a particular company. There's a written examination, right? Written examination, then after you pass, you will call for the initial interview, and then secondly, you need to do the panel interview, and then you will be selected. There's a step by step. But kung pipitsugin lang, things like that, there's no such step by step. You get the point? Meaning not world class. Usually the world class companies, it's not fan of referral. Again, world class companies like Saudi Aramco, Saudi Kayan, it's not loving of referral because you are the friend of like this, you are the cousin of like this, you will be automatically the engineer of like this. It's not like that. There's no politics. You will really apply, go to zero, whoever you are. Okay, equal opportunity, things like that. Okay, regardless of gender, regardless of capacity, regardless of the religion, regardless of your intelligence, regardless of who you are, all of you will go back to zero to test who among you will shine the brightest, things like that. But for the pipichugin, pipichugin, it's not world class. Okay, the products are produced locally only. They will not go to another countries for exportation. It will be produced only in that particular region. Okay, so it's not like that. More on politics. I know this guy, then apply there, and they will be picked up like that. Okay, through connection. But it can never be done in a world-class company and industries. It will be obvious because they have a very competent and very expert recruitment there. Okay, get the point? And their BI is so strong. BI, background investigation. You cannot falsify documents that you are engineer. In fact, you did not finish your college education. You are a licensed engineer, but in fact, you are only falsifying and fabricating your license certificate. Okay, then you are telling that you passed the debush, then actually you are not. You are only fabricating your certificate and diploma. You can never do that in Saudi Aramco, Saudi Kayan, and to those world-class companies that having a high standards. The BI is so strong. BI stands for background investigation. They will call the schools where you graduate. Okay, they will really search in the websites if you are really certified auditor and you're claiming you are a safety auditor globally, but you are not. Okay, so you should pass the 2007, 2007 OSHA's lead auditor 1437 to become a world-class auditor in safety. You get the point? So that's true. I did not practice that one because I did not settle to become an auditor, but I passed the international auditor exam. Okay, facilitated by United Kingdom. Okay, so I have a credential like that. So you cannot falsify that one. You get the point. Okay, and you cannot also falsify Nibush because in the website your master logbook certificate number will be encoded, and if you are not there, you are a legit passer. But before they can cheat, a lot of safety professionals all over the world can cheat, especially Gulf countries and Middle East. That's why you can observe also safety engineers and some officers and managers that are not radiating and echoing their actual performance. It's not matching to the records. That's the reason. Okay? Because they are not really legit. They are not all, but few and some are fabricating their certificates. The same also with other professions, not only in safety, in quality management system, in environmental management system, like the whatever, chupa. So it's the standards of ISO is gonna be like that nowadays. In world-class companies, multinational companies, the screening process is so tough and challenging. For example, in our country of origin, in Coca-Cola Philippines Bottlers Incorporated, San Miguel River Corporation, you can never really cheat as long as you are really the predecessor of that particular, let's say your father, okay, will resign, then there's no such screening anymore. You try to speak to your son, apply there, things like that, okay. But again, you go back to the zero. You get the point? Process. But of course, as a father, you need to ensure that your son also is a legit licensed chemist, okay, licensed engineer, because Coca-Cola and San Miguel River Corporation will not accept if not registered chemists and registered chemical engineers. Sorry to tell you this, they will never accept if you are not a licensed chemical engineer and licensed chemist in their labs. Even though you ask one by one, they have all, because their standards are so high. You get the point? So, because I'm there before in Coca-Cola Bottlers Philippines Incorporated. So it should be a licensed engineer talaga ang part sa ilang requirements. Okay. So you can do it by yourself. You can ask one by one there if you want to really prove what I'm saying is correct or not. Okay? I'm telling you like this because I've worked there before. You got the point, it's so standard there. And every 6 months, there's an examination, okay, to calibrate the analysts, the chemical analysts in the lab. For example, in the Cebu, Tagbilaran, Camarines, like that, because the nationwide Coca-Cola is nationwide. And then you need to compete for the standards, for example, quality, beverage index, like that, the mass production, things like that. So there's a competition also all over the nationwide and shop. Okay. Would you believe it or not, guys? At my time, we are the number one in beverage product quality index. Sorry. During my time there in Tagbilaran, nakindi na po ang Cebu and Manila, Luzon. I'm not telling that I am the one who do that as a team, but you know, I'm just very happy because during my time we won. And quality is the number one award to be fight because that it talks about quality when we are in the laboratory, right? So it should be the word quality. And the other awards are really relevant. It's also okay, but the main topic of the award is the quality, of course. You get the point? Because you are in the quality department, quality assurance and quality control department. Of course, you are fighting for quality performance. You get the point? And at my time, we are the number one. Okay, shout out to Ma'am Rona, my supervisor in the chemical laboratory department of Tagbilaran, Bohol, si Sir Ondoy, okay, si Sir Pep, okay, ako mga team before in Coca-Cola Battlers Philippines Incorporated in Tagbilaran. Okay? So shout out, you still remember? I still remember your names actually. Okay. Things like that. Okay, number 4. So we have chloropentane structural formula. Okay. So how can we do this? Okay, pentane. Right? Are you still alive? Because it's still morning. Oh, no, it's afternoon now in the Philippines, right? Okay, you can stay by me. Okay. So chloropentane. So pentane. 1, 2, 3, 4, 5. Then 1, 2, 3, 4, 5. Then 1, 2, 3, 4, 5. Right. Then chloro. The number of chloro attachment is not specified. So you could guess either in the carbon number 1 here and carbon number 1 here also. It depends. Okay? You get that one. As long as if it is in the carbon number 1, you don't need to put number in your name. Okay, so the chloro will be here, say for example, okay, in carbon number 1. So the rest will be hydrogen na. Hydrogen, 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 hydrogen. Then, you know already what to do the condense because I told you, right? Just follow the pattern. Okay, and have it by yourself. Okay. Sorry, you cannot post that video while doing that. Okay, let's continue. So number 4, pent-1,3-diene. Pent-1,3-diene. Okay, no? Okay. Now, it's possible also that there's numbering, but there's no attachment. It would only indicate the numbering on the bands it contains. Bonds here is B-O-N-D-S, huh? Like a bond paper, not the band, B-A-N-D. Because there's, you know, how to pronounce it, band and bond. Okay, this, I'm talking of bonds. You get the point? Things like that. Okay, so, pen. O, 5 na yun. 1, 2, 3, 4, 5. Then, diene. Okay, die, meaning 2. Okay, and YNE is a triple bond. Okay, ANE, single bond, double bond is two hyphens, and then 3 hyphens, okay, is the triple bond, like this. Alkane or ANE, double, ENE, triple, YNE. So use the YNE because see, diene. Okay, now, your number is 1, 3. So it's in the carbon number 1, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. What I like the most in organic chemistry, because you are just like playing a game. And at the same time, it would be fun to do that every time during your steps in a day. Okay, things like that. I will master that for how many semesters? Like that. And in fact, I have a higher grade of organic chemistry compared to my major subjects. Okay, I'm not that having a very high scores or grades in unit operations, my major, but for the chemistries, super. Things like that. So I like chemistry that much. Okay, so I think, I really scrutinized last night. I have 4.6 grade. Because in CIT, our highest score is 5. When I check my transcript of records, it's 4.6. So meaning to say, this is gonna be 96%, right? Oh, I love that. So I will smile, looking at my transcript. Wow, how amazing it is. Okay, because according to others, chemistry is difficult. Things like that, and especially this is organic chemistry already. Because, I do it with commitment, dedication, I enjoy, and then I'm willing to learn. I'm happy what I am doing, like that. It's not forced study. Okay? So meaning to say, I'm not reluctant. Okay? I always accelerated and have the passion of tremendous study of this particular context, which is chemistry and overall picture of chemistry, or the whole framework of chemistry. What we say, whole framework, meaning starting from inorganic, organic, analytical, physical, all about chemistry. You know what I mean. Okay, things like that. Okay, now we have 1, 3, no? So 1 here. Okay, the 1 here we put the tripole. YN is 1, 2, 3. And then carbon number 3 here. So 1, 2, 3. You have to put the 3 hyphens signify for YNE, the triple bond. Okay. Now budgeting your hydrogen. Okay. In carbon number 1, you have already the 3 bands of your triple bond. You need only to add 1 hydrogen. Again, for the reason that carbon has 4 valence electrons in the outermost shell. Okay. In carbon number 2, so 1, 2, 3, 4, you don't have to put hydrogen anymore because all are being used up alone in the chemical bonding between carbon number 1 and carbon number 2 and also carbon number 3. You get the point now. Starting for carbon number 3, already also budgeted the 4 valence of electrons. You don't have to put also H here. See? 1, 2, 3, 4. How about carbon number 4? Okay, it's also budgeted. See? 1, 2, 3, 4. Okay. Last, carbon number 5. So you can now spread the hydrogen here a lot. 1, 2, 3. And take a closer look and visual inspection. 1, carbon 1, okay. Carbon number 2, okay. Carbon number 3, okay. Carbon number 4, okay. Carbon number 5, okay. So, the more you have double bonds and single bonds, the attachments of your hydrogen will become less. Okay, that's a logical interpretation somewhere along the way. You get the point? So you could not expect the hydrogens are always higher in number, in quantity, if we are having a lot of double bonds and triple bonds. Okay, now let's go to the condensed structural formula. Okay, so condensed, no, so it's gonna CH. In condensed structural formula, you don't have to account the bonds. Okay, only the elements. C, right? C, and then CH3, CH3O. So CH, CH3. Okay, rearrange. So CH, then put the carbon, close and open parenthesis, 3. Like that, supposedly. Since carbon has no partner, okay, that's why you don't have to put parentheses. Only C3. The parenthesis only will be put if it contains more than 1 elements, or in math, more than 1 variables. Okay, for example, you will say, XY parenthesis 2, XY2. Now, if that is only X, then you don't have to put parentheses, only X2. So the same thing with science or organic chemistry or chemistry, whatever. Okay? So the same principle will apply. Okay, it's gonna be C3 only, no need parentheses. Okay? We should say, what is the condensed structural formula of chloropentane? And you will give directly without starting for the structural formula. I will salute you if you can do it immediately. Things like that. Because there's no emphasis on the double bonds. So it's very difficult, okay? Trust me. You need to start with structural formula. Okay, number 5, 3-butanol. Okay, if talking about alcohol, okay, the concept will change. Okay, that's the point. So the UL will be on the last in the naming, always in the alcohol, ha? Okay, and then the counterpart will be YL and OL. For example, this is meth. Okay, so methyl. Okay, meth plus YL, methyl. Okay, then OL sa last, methanol. Okay, because the word methane will be carried over. And then plus OL. And you need to drop the E. So just like in English, right? If you sing, for example, change Y to I and add ES. Okay, the plural of something, right? There's so many examples for that. Okay, so that's plural and singular. Also applying in science like this, also say methane plus OL. So change letter E to O. So this one, methanol. Okay, that's alcohol. We drop the letter E in the last letter of the hydrocarbon. For example, octane. So drop the letter E, it will become octanol. Okay. Ethane. So that would be ethanol. Drop the letter E because that's the role of OL thing. Okay, got the point. But for the YL thing, you need to cut off the prefix. Meth, pent, but, oct, nonna. It will become nun. Nunanil, like that. Okay, nunanil, ethyl, isopropyl, ethyl. Okay, like that. Okay, and then pentyl, heptyl, hexyl, like that. Okay, so that will be for alcohol. Methanol, propanol, butanol. Okay, decanol, dodecanol. Okay, now in octane, octanol. Okay, things like that. So then you can apply that somewhere along the way in naming them. Okay, so butanol. So that's but and NOL. Coming from butane, we drop letter E, as I told you a while ago, to say butan. Okay, so that's still 4 carbon atoms. 1, 2, 3, 4. But take note, the number 3 is mentioned. Okay, so it's mentioned in carbon number 3. So you start from the left. 1, 2, 3, 4. It's in the carbon number 3 that you will attach the alcohol thing. You get the point? So the alcohol thing here, of course, is butanol or butyl. You get the point. So what is the butyl formula? So if we will speak generally, alkyl, okay, or let's say OL, okay. So butyl, okay, it came from butane, okay, like that. So you need to have C2H5 here, C4H, wait, C4H, I think it's gonna be 10. Okay, memorization technique. Okay, so C2, let's go back to CH4, wait, C2H6, C3H8, C4, yeah, C4H10. You will remember always during your memorization that the gap of the carbon atoms, 1, and the gaps of hydrogen atoms, 2, in ascending order, meaning increasing. Okay, see? 4, 6, 8, 10, 12. But if you forgot that simple clue or strategy in memorization, use these 3 formulas in hydrocarbon. Okay, single band, CN, H2N plus 2. Double band, CnH2n. Okay, ana lang siya. Triple band, CnH2n minus 2. So these are the hydrocarbon formulas in case you will forget the sequencing of your hydrocarbon compounds. Because sometimes you will be confused somewhere along the way, right? Okay, just like me a while ago. I almost lost also. Okay, then I can use this. I have another option. Okay, so that's gonna be definitely safe for H10. Okay, to prove, okay, prove. 4 carbon atoms, it's gonna be in the alkane. Single bond. So C4H2 times 4 plus 2 is gonna be C4H8 plus 2. So C4H10, perfect. This is really the formula of butane aside from knowing the sequencing of the carbon atoms and hydrogen atoms. Okay? Take note guys, this will not be discussed clearly in chemistry. It depends on the teachers. Okay, because there are other also teachers that will go directly, will not emphasize. Take note also. Okay? Okay, so number 5, 3-butanol. So, it's in here your C4H9 because minus 1. Okay? It's gonna be like that. So, butanol minus 1. It's the hydrogen will be deducted by 1 kasi. Because hydrogen will react, not the carbon. Why is this so terrible? Because from the common sense, hydrogen is the lightest element in the universe. This is really reactive most of the times, the hydrogen. Most of the times, it's always. Okay? Because this is very light. The electrons of hydrogen is very, very light. Okay? So do not confuse when I say the electrons of hydrogen is very, very light, because you only see the proton, which is positive 1, as I told you. An atom, a single atom, composed of 1 electron and 1 proton. Okay, we are talking here with a quantity, meaning the same quantity. We are not talking with a sign. Okay, if you talk for the sign, then electron is negative. But in the chemical bonding, in electron sharing, we don't have to account the positive and negative sign of your electron and proton. Okay, that's why we will always say electron sharing, electron transfer. We will never say proton sharing, proton like that. Okay, it's always electrons, because for the reason that a single atom composed of the same number of electron and proton, not accounting the sign. And another reason for that, okay, electron is very light. Okay, 9.11 times 10 to the negative 31 kilogram is the mass of 1 electron in an atom outside from the nucleus. You get the point? So if you will review the John Dalton atomic theory and the Niels Bohr theory of atoms, then you can understand. Then not enough, you need to associate to study the cell biology also. Cell. Because in a cell, there's a lot of, nucleus like that and the parts of the cell. So that you can attach chemistry there. That's why we are now having the knowledge of biochemistry. Okay, linking and attaching or collaborating chemistry and biology concepts. That's why biochemistry. Okay, so at least we need to be versatile in our understanding. We don't need to focus only in one, in one science topic. When we discuss. During our discussion, we need to attach the other related science so that it's very easy for us to share the knowledge to our pupils and to our students with regards to chemistry, various types of chemistry. Okay, now going back to butanol. It's gonna be like this only. Okay? Things like that. And then, what's missing here? C4H9, since OL, you have to put OH. Because alcohol you attach. Okay. You attach the butanol or the butyl alcohol in carbon number 3, and the rest of these carbon atoms in 1, 2, and 4 will be hydrogen. And no need to emphasize because we keep on repeating the same story. Things like that, and then we already understand, right? Okay. So it's gonna be like that. So if you try to take a look, so that is highly flammable because you attach the alcohol here. Okay, things like that. Okay? Now let's prove why flammable. Okay, because that is nonpolar covalent compound. Okay, guys, guys, if the more it is flammable, the more it is, completely share the electrons. It looks like the reverse in our understanding, right? Just like water, because the more it will attract other compounds, other substances, because there's an excess electrons that needs to be paired. But in the concept of chemistry, the more it is being shared all throughout, which undergoes nonpolar covalent band, especially all types of hydrocarbons. If I will say, for example, it's a random example only to have why we say that all hydrocarbons are flammable. Okay, things you don't need to go back with the NSDS and the safety data sheets just to check if it's flammable or not. As long as you have an idea regarding the covalent bonding, then bingo. Okay, because sometimes you don't need to keep on looking the safety data sheets. If you have the knowledge already, this is going to be a polar molecule, non-polar, it's going to be flammable. So things like that, okay? So let's say starts with octane. Octane, I love it. Octane family, example is gasoline. Okay, things like that. So the gasoline is the member of octane family in our hydrocarbon. Okay, so what is the carbon in octane? 8. And then in synchronizing, so 2, 4, 6, 8, 10, 12, 14, 16. Okay, so to avoid keep on memorizing like that, use the formula Cn H2n plus 2 and your 8 atoms of carbon. So C8 H2 plus 8 plus 2. It's gonna be C8 16 plus 2, guys. C8 H18. So we have 8 atoms of carbon and 18 atoms of hydrogen. Okay, this is the chemical formula, molecular formula, and general formula of your gasoline or your octane. Octane is general, gasoline is specific. Okay, you get the point. So now, I could say that it is nonpolar covalent compound, right? So let's prove it. So 1, 2, 3, 4, so many, right? 5, 6, 7, 8, and hydrogen spread. Oh, evenly distributed ang H. See, what can you see here? So, all of them are happy. They share the same blessings, both the carbon and hydrogen. So there's no walang tapon. They receive the same blessings, meaning they shared all the electrons without lone pair of electrons and without excess electrons unshared. Okay, the more it is perfectly shared, now your substance is flammable. Okay, you don't wait for the technical values, let's say 2.8 degrees Celsius, flammability point, ignition point, like you don't wait for the numbers. By looking with the theories and principles, and we can say if it is flammable or not. If you know the general formula and the structural formula of the chemicals and the substances you use and you encounter. You get the point? So that's it. Because sometimes also the safety data sheets are not available, then of course I will die if that is flammable, then I have the ignition, maybe it will cause a fire. So that's why it's very obviously I will take note the chemical and physical properties of the particular compounds and substances, alright? So it's gonna be, again, all flammable substances are non-polar covalent compounds. Okay. Okay, number 6, dimethylbutane. So what is your structural formula? Dimethylbutane, again, there's no numbering, so you can put that in carbon number 1, either in the left and right, things like that. Now, there's vague or gray part in this area, gray in English, meaning to say confusion, G-R-E-Y, skeptical, confusion, you will be baffled, you will be steered, you will be perplexed, you will be confused, you will be so enigmatical, like that, abstruse, difficult to comprehend, equivocal like that, things, and you need, very difficult to interpret. So all types of synonyms in English language, it's just the same meaning of confusion or confusing. Okay, subject to so many open interpretation in that particular one context. There's a lot of understanding. So we have a gray area of this number 6, meaning confusing part, and we need to explain. Okay, dimethylbutane. Okay, so 1, 2, 3, 4. Because this is butane, only 4 carbon atoms. So 1, 2, 3, 4, 4, 3, 2, 1. I said a while ago, I don't have really to be concerned with the number. Because we said no number here that could be put in the carbon number 1. Now, if you put all methyl in carbon number 1, because there's no number here, then it will not be dimethyl already. You get the point? Things like that. So, how can you do that? Okay, dimethylbutane. Okay, 1, 2, 3, 4, and 4, 3, 2, 1. Ganon. So, it's gonna be in carbon number 1 yung dimethyl, CH3. Okay, things like that. H, 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 H. Okay, things like that. Okay, so there's another one, methyl. So in what carbon you will attach that? Okay, things like that. Get the point? In what carbon? So you need still one, another one. Since this is understood to be 1. So let's say 1, 1, dimethylbutane. So it's here. Okay? In the carbon number 1 also. That means 1, 1 dimethylbutane actually. Okay? 4, 3, 2, 1, and 1, 2, 3, 4. Okay? 4, 3. Okay, in the 1, carbon number 1. See? Get the point? Wait. So let's make it clear again. There's a gray area. Okay? This is understood to be 1, 1 dimethylbutane, right? Okay. So my brain itself corrected immediately. So it's impossible that the 2 dimethyl will be going there because it would create another band. So let's draw it again. So 1, 2, 3, 4. Okay, let's do it again for the second time. So test trial like that, because science is always through experimentation. Test 1, test 2 until you succeed. You get the point? That's experimentation all about. Okay, you need a lot of data. 1, 2, 3, 4, 5 until you succeed. So now validate your experimentation. It looks like it's normal in pure science. Okay? Things like that. So the first option will be wrong because if you put CH3 here, the single bond here will be adjusted. Okay? So 1, 2, 3, 4, right? 1, 2, 3, 4. So I told you the gray area. Okay? So if you say dimethylbutane without number, it's in the carbon number 1, right? So the carbon number 1 is in the right and the carbon number 1 also in the left, in both direction. And you put CH3 there. Sorry in the first, because I count the 1 also going to the right, the same pattern of the numbering. That's why I was confused. Oh, there's 2 CH3 in carbon number 1. Okay, things like that. So this is gonna be your dimethylbutane. Okay? So opposite, because the carbon number 1 is opposite on the other carbon number 1. So this is gonna be the same as 1, 1 dimethylbutane. Okay? Or not putting 1 at all. Because if you don't put the number, you will confuse you because you don't know where exactly to put the CH3 as long as there are 2 methyl you put. This is the gray part I told you. And this is di. This is only 1. So if you say methyl only, it's easy. It's in a carbon number 1. But it's di. So you have to put that in carbons in number 1 position. So consider the both direction. From right to left, from left to right and right to left carbon number 1. So there are 2 carbon number 1 here. Here, from right to left and left to right. So put the CH3 there. Okay, so don't be confused if there's no numbering in your name of your compounds and substances, because that's understood. It should be in the carbon number 1, okay, or in both carbon number 1, in the, both direction. If it is di, like that, blah, 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 so and so. If it will say 2,3-dimethyl butane, you put in the carbon number 2 and number 3, it's very easy, right? But if there's no number, that's only confused us. Okay, things like that. Now take note also in chloropentane in example number 3, when you attach halogen, the rule in IUPAC chemistry, International Union for Pure Applied Chemistry, it will be in the prefix. See, chloropentane, bromohexane. It should be in the first, not in the last. You say pentane, chloro, hexane, bromo. No, it's in the first always. Okay. So you need to understand what is prefix, and you need to understand also what is suffix. Prefix, first, prior to the root word, and then suffix will be in the last after your root word. Okay, get the point? Ganon. Example, removal, or re is your prefix. Okay, things like that. Okay, so claro? So things that's very clear, right? And now, let's say chloropentane. Chloropentane is the minimum requirement of a cyclic structure. Remember this, guys, in naming organic compounds, you can have the version of Haworth. Haworth meaning the cyclic rings, starting from furanose, meaning 5 sides of the ring, meaning pentagon. Like this, pentagon. Since in our example, 1, 2, 3, 4, 5, we have pentane. 1, 2. Okay, only 2. Example number 2 and example number 3. We can have also our equivalent Haworth structural formula in terms of cyclic rings. But the other, no need, because it's only 4. See, butene, 4 carbon atoms. Things like that. Also number 4 pala, sorry, this pent. Okay, and then number 5 also but. Okay, but. So we need to say from methane, ethane, propane, butane, there's no equivalent cyclic structure aromatic formula for that. Aromatic hydrocarbon. When we mean kasi of cyclic ring, guys, we mean that is aromatic cyclic ring structure. Okay, aromatic cyclic ring structure. Okay, that's the complete package to understand. Aromatic cyclic ring structure. Other will also say benzene ring, but it doesn't mean benzene. It's only carrying the ring of a benzene. That's why it's also a little bit of confusing. Maybe the students will put always that 3 double bonds inside the hexagon. So that's why I don't, in my college, I don't prefer to use benzene ring. I will always say cyclic ring. Like that, okay? Pentagon and hexagon. In my study pattern, you get the point? Because benzene have like this, right? Double bonds in here, here, here. Three double bonds inside the hexagon. So you will see benzene ring all the time. So it will confuse us because our substances are not benzene in the first place. You got the point? Ganon. So just call it ring, cyclic ring, or aromatic cyclic ring. Ganon. Okay, now, in case of chloropentane, what is the equivalent for this? So you need to draw the pentagon. See, 1, 2, 3, 4. So 1, 2, 3, 4, 5. So 5 sides now because 10. Then single bond, there's no double bond inside this cyclic ring because A and E. Now the rule in cyclic ring, your carbon number 1 will start in the shoulder of that particular polygon. What is the shoulder here? This one, right shoulder, and the other one shoulder. This is for the pentagon. For the benzene. So that dito maglibog because there's so many starting point how to put the number 1. So let's agree. Because the moment we will be wrong in the starting of the carbon number 1, all our naming of this Haworth cyclic structure compounds will be wrong entirely because we put the number 1 in any order. It should be in the shoulder of the polygon, in the hexagon or in the pyranose. Okay, shoulder also here. Okay, now, carbon number 1 here. 1, 2, 3, 4, 5. Oh, here. 1, 2, 3, 4, 5, 6. Oh, see, level say 6 chloro. Then put the chloro here in the 6 like this, okay? You get the point. So, chloropentane doesn't mention. So, what is our rule in IUPAC chemistry? It doesn't mention the number. Cetal to carbon number 1. So, attach the chloro here. So, Cl. When you attach, you don't carry the negative charge of chlorine because this negative will react to the H in this particular carbon in the shoulder. Ano naman siya? Carbon H plus carbon chloride. Then the chloride, okay, is very hungry because that is electronegative. So since hydrogen is very strong, then it will really pull the electrons of hydrogen to be donated in the negative of chlorine. That's why the chlorine here during the contact will become positive now without charge. Okay, so you need to understand the principle of, it's gonna be the Arrhenius theory, I think. Okay, positive ion. Yeah, Arrhenius theory of basicity and acidity. Okay. So you should remember the Lewis acid and base, Arrhenius theory acid and base, and also the Lowry-Bronsted acid and a base. So if you mean Arrhenius theory, basic only. Okay, if you say Arrhenius theory, it will yield positive 1 ion in a solution, in an aqueous solution. When you say Lewis, that's only donating and accepting of electrons, meaning electron sharing and electrons transfer, that is chemical covalent bonding, things like that. And we mean of Bronsted-Lowry acid, that's why slightly basic, slightly acidic, by donating the protons, protonated, deprotonated. That's in the case of our amino acids. You get the point? So each theory, there's a corresponding application where to apply. Okay, here our attachment involves inorganic only. See, H and Cl, hydrochloric acid, so inorganic. So apply the Arrhenius theory. You get the point? So you will never take care of the balance of electrons. Because, Lewis theory acid of base, always consider the electrons. Okay? Things like that. In here, no, it's not. Okay? You can consider the negative and the positive charge. Now, put the chloro here in the carbon number 1. Now, that is chloropentane. Now, if you have the chloropentane in this number 3, the naming in your cyclic structure will change. It will become cyclochloropentane. Okay, you always add cyclo. Okay, cyclohexane, cyclopentane. But in this case, there's a chloro kasi. That's why we say cyclochloropentane. But take note, some books are dropping the word cyclo because it's understood that it is a ring that is already cyclo. Okay? But what I'm trying to emphasize, we need to follow the ideal way of naming kasi in IUPAC chemistry, International Union for Pure Applied Chemistry. That's gonna be the exact way of naming. Because some books and textbooks, based on my scrutiny when I was in my college days, it will remove in the naming. That's why chloropentane only. But actually that is cyclochloropentane to make it meticulous, or strict, or rigorous in naming. Okay. So you get the point? Meticulous, rigorous in naming, things like that. Okay. So, perfect. So that's our examples, carbon number 6. From 1 to 6. Now you can name na a lot of unique different substances in organic, right? Most of our food is highly organic, right? So we can apply the theory of organic chemistry. Most of them. Okay, fruits and vegetables. Okay, so that's why the most interesting and most enjoyable topic in taking masterals of chemistry is biochemistry. That is more challenging. Okay, because it talks about life in the bio part. Okay, it talks about the cells, anatomy, physiology, like that, and epidemiology, the diseases, and the diagnosis and the treatment, how to control and how to eliminate the disease. So very important in our life, and the chemistry in it to understand the behavior and the process or the reaction of substances inside our body. Okay, things like this. So that's why this is the most challenging coverage in taking up Masters of Chemistry. Or in the other version, Master of Science in Chemistry, or Master of Arts in Chemistry, or Masters of Education major in Chemistry. Okay, things like that. You get the point? Now, what's the difference between the three? Okay, Masters of Science in Chemistry, you are having the thesis. Okay, the thesis of having your experimentation like that. Okay, things like that. But your Master of Arts in Chemistry, it's non-thesis. Okay, you'll be given only a project, things like that, and a comprehensive exam, equivalent to the thesis of the Master of Science. Okay, but the same degree chemistry. Okay, the Masters of Education in Chemistry, it talks about teaching profession in the details of chemistry. All. Okay, that's their concentration. They can also work in industries, but they prefer to work in academia or academic universities, schools like that, or any public agencies, research and development. But this Master of Arts, Master of Science in Chemistry, you will work in the process industries for the product design, okay, and conceptualization. Okay, to produce the desired yield of the product. So they have to, research, because they have in-depth knowledge in chemistry. Because, all products starts with, composition and ingredients. Okay, because that's matter. Okay, the study of matter and the changes it undergoes, whether it's physical change and chemical change through chemical reaction. Okay, chemical reaction or chemical separation processes, and physical separation process, or physiochemical processes. So things like that. You got the point? Physio is a combination of physical and chemical processes in one time. It's a physiochemical process, and it involves also physiology somewhere along the way. You get the point? Ano siya guys, no? Okay, then dito sa Masters of Chemistry, nindot ko lang environmental chemistry in topic number 4. Okay, so ano na siya guys? Inorganic chemistry, okay, things like that. Okay, organic chemistry. Yes, organic chemistry. And then next will be the analytical chemistry, the technical analyst people, or the chemical analyst people, analytical chemistry. More on the labs. Okay, it's gonna be quanti and qualitative chemistry. Okay, what's the difference between quali and quanti? Quanti is measuring of different analysis tests and technique. Okay, talking about the quantification and the composition. Okay, the quantitative stoichiometric amounts of the particular sample. Okay, but qualitative, you need to determine what are really the substance present of the unknown samples that our instructors are introducing, in which we don't know yet things, and we need to analyze what's being there. So that's qualitative. Okay, unknown samples. Here, unknown quantity or stoichiometric amounts. Let's say 2 grams of sodium chloride through calculation. Here, we need to determine that it is really sodium chloride in there. So that's the difference between qualitative and quantitative, and that's all analytical chemistry. So number 4, we have the clinical chemistry and the medical chemistry. Okay, this is applied in hospitals and the health professional people, the taking medical science. You get the point? All about blood chemistry, urine chemistry, protein chemistry, things like that. We have to study that the substances inside our body. That is clinical and medical chemistry. It's very important also, right? Okay. Number 5, we have biochemistry. Biochemistry, if you cannot understand very well biochemistry, mga muti ka sa clinical and medical chemistry. Because clinical and medical chemistry, it has an application with the technology. But you have a very comprehensive knowledge in biochemistry, the theoretical aspects. Okay, you get the point. So that's why the medical technology profession will get the sample of the blood and the urine to test, and he analyze what are present in that. It could be the creatinine, uric acid, urea, like that, or salts, or glucose, electrolytes, bilirubin, the bad protein, like that, whatever. Okay, AST, ALT, the liver enzymes. Okay, get the point, things like that. Number 6, we have environmental chemistry. I love it. Okay, this is my first love in Masters of Chemistry, environmental chemistry. I love this. That's why I took up to study in USC Talamban as my master course, undergraduate. I'm not finishing that one, okay? Things like that. Because, it attached in my profession in safety. HSE, health, safety, and environment. And it's easy for me to, to collaborate with other profession in HSE, environment. Now, to tell you honestly, guys, there's a lot of offers to me regarding environmental engineer like that, but I decline because I prefer to work in OSH talaga, things like that, okay? So, there's offer, but I'm not yet ready to become an environmental engineer, things like that, because I did not try. Okay, because they will look at my credential that I have the Masters of Science in Environmental. That's why siguro. Okay, they will try to call me sometimes, not all the time, sometimes only. Okay, so the knowledge of environmental chemistry will be on the air, okay, land, and water. Then we need to have environmental monitoring. Environmental monitoring to determine the quality of our atmosphere, air, and our hydrosphere, water. Okay, and our, what is the land? Lithosphere. Okay, the equivalence in that, right? If you can still remember, earth science in high school, we talk about hemisphere, stratosphere, mesosphere. There's a lot, atmosphere, like that. You get the point. Okay, the lithosphere, hydrosphere. So it talks about sphere because let's say the world is like a round, okay, like a circle. That's why a sphere is also a round. That's why sphere. And they add only the prefix denoting the Greek meaning of something. We said letho, that is soil. We said atmo, that is the air or the atmosphere or the gaseous components in the planet Earth. When we say also hydro, that is water. So adding that, we got hydrosphere, lithosphere, atmosphere. Okay, but the prefix are Greek, G-R-E-E-K, from Greece. Okay, you got the point? Because most of our scientists will always use that Greek language before. For example, alpha, beta, gamma, okay, epsilon, okay, rho. So until now, our students from universities and colleges all over the world are still practicing that until now because that's the coverage of sciences really in computation, especially in transmutation chemistry. Transmutation chemistry, it deals with radiation. Okay, alpha ray, alpha emission, beta emission, beta ray, gamma ray. Gamma ray is known as the X-ray. Things like that. You get the point? So using Greek words also. So that's why most na siya ang environmental chemistry, mga Greek. Atmosphere, lithosphere, like that. Okay, the air quality, the land and soil quality, and the water quality. So we need to avoid environmental degradation and environmental pollution. Okay, that's why when you are an environmental engineer, you are closely related to being a pollution control officer or PCO. Because it has to do something with the environment. You get the point that most of the people hired there are chemical engineers, okay, and chemists. So either chemists, or science professionals. They are highly preferred. It can be stolen and taken by the other course if they have training. This environmental, if we studied a little bit with environmental also, but if they don't have experience about environmental, it's impossible for them. They will become the PCO. At least they have the training. Okay, but chemical engineers and chemists are advantaged in this kind of possession. Get a point to control the pollution in the air, land, and the water. And we need to have environmental monitoring. Okay, so we need to measure the hazardous air pollutants, the toxic contaminants like that. Okay, in parts per million. You know how to compute already. I discussed it already, right? Last month, how to compute parts per million concentration of a gas. Okay, then it will be fun, right? And then we need to climb in the chimney. We need to analyze the gaseous components there, things like that. You get the point. Usually black, right? And then we need to wear our PPE and we use the device, okay, to measure the percentage of, let's say, SO2, carbon dioxide, carbon monoxide to maintain the air quality, environmental, right? Okay, things like I have experience in that also in National Power Corporation in our place because we have power, okay, power industrial plant. And I did my OJT there on the job training when I was in fourth year college. Because that's a requirement. Before you will graduate in chemical engineering, you will be exposed in OJT, actual doing your job. And it happens, I'm accepted in the Salcon Power Corporation in our place itself because you know if you are on that particular place you are really the advantage, the locality principle in our government. If you are there, there's also products related there or you know different industries, they will be also there in your area. Okay, that's the time. So it's so enjoyable. I analyze fuels. Oh my gosh, I love it. I could remember. Okay, distillation. Oh my gosh, I love it.